Welcome, everyone, to today's conversation on infrastructure agility and cloud portability. Over the next 30 minutes, we're going to explore real-world challenges companies face and how Kubernetes is changing what's possible. So to help us unpack all this, I'm joined by two incredible experts, and let me introduce you to Derek Sutherland, Chief Architect at Shadow-Soft. He's a seasoned cloud and Kubernetes architect with over 15 years experience helping enterprises modernize securely and efficiently. His journey has taken him from hands-on engineering and automation to leading architecture teams and guiding complex transformations across industries. We've also got Nish Rama, RVP Solution Engineering at Dynatrace. Nish is focused on harnessing intelligent technologies to drive operational excellence, elevate customer experiences, and unlock new growth opportunities. With a deep understanding of enterprise dynamics and emerging AI capabilities, he helps organizations move beyond automation and towards true intelligence. Welcome, gentlemen.
Hey, how are you?
Pleased to be here.
So let's kick us off. Question for you, Derek.
Sure.
What are you hearing from customers about cloud lock-in concerns today, and what's driving companies to prioritize workload portability?
It's an interesting way of wording it. And the reason why I say that is because if anyone's been really watching the news in the last several weeks, let alone the last year, obviously the Broadcom acquisition happened, and that's not specifically cloud, but they think about moving from one environment to another. And then we're seeing kind of what's happened with AWS, especially in the last several weeks as it relates to major cloud outages. And now we've seen the exact same thing only a week removed from the AWS major outage, a full global Azure related outage. So some companies or some people are saying, oh, doesn't really matter to be multi-cloud. See, it could happen anywhere. And that is 1000% true. In fact, it only lends more credence to why we need to be portable, but people don't think about portability in general terms because they think it's impossible. What they think about is I can be multi-cloud and then therefore have some of my customers be in one environment versus another. And if an environment fails, I'll fail over from one environment to another. It's a great way of handling it with the restrictions that people perceive we have today. But I think ultimately what we're looking at is a precipice of you can't be coupled to any provider, whether it be your own infrastructure you own, whether it be Azure or AWS or Google. I mean, I literally put a post up earlier today, like, are we looking at the trifecta? Is that what's coming next? Google's going to collapse on itself? I hope not, right? But my point process around this is most people think that having a multi-cloud strategy in the essence of I'm in multiple clouds is the answer to this problem. And the truth of the matter is it's about being interoperable, being environment agnostic, and ultimately being portable. And I think where people stop thinking portability can be possible is they go, oh, I can put something in a VM or I can put something in a container, and that's where the portability ends. When really I think there's a lot more that there's available to us, given that we have so many more open standards that can work everywhere. Ross, you're on mute, buddy.
Nish, any thoughts on that?
Yeah, I would agree. When we talk to our largest enterprise customers, they, when they talk about their cloud strategy, essentially they're saying the exact same thing, right? That, we run workloads in Azure, we run workloads in AWS, we run workloads in GCP. And then when you get down to the brass tacks, they're essentially the same workload, right? And so the question becomes, why not create or start when you think about, that workload, whether it's an AI workload, whatever, why not create that level of portability from the start? So that way, it's just a config file that I can go move, whether it's EKS, AKS, GKE, whatever. Right. It shouldn't, the limitation should not be on, the technology, the underlying technology. It really should just be, hey, can I take this config and this workload and move it to wherever it needs to be? Right. That's really the way, the future really. And that's the way that companies should be thinking about a multi-cloud strategy. Yeah.
Mm-hmm. So Nish, like how has Kubernetes really changed the conversation around infrastructure flexibility and that ability to move these workloads between cloud environments?
Yeah, it's exactly, kind of what Derek alluded to before, which is that it think about it more from a configuration standpoint now, right? So when you think about Kubernetes, it's a YAML file, it's a Helm chart, it's whatever it is, it's really just config, right? So when you're deploying a workload, think about being agnostic from the start, right? So think about having as much of your config as you require within the file, within the YAML file itself. So that way, when it comes time to deploying the Kubernetes workload, the underlying architecture is, the underlying nature of Kubernetes doesn't necessarily change from cloud provider to cloud provider. You know what I mean?
Mm.
So when you think about deployment now, it should just be as simple as, hey, here's my file, here's my config file for my JVM or whatever, right, my Windows containers, etc. I'm going to go take this now and I'm going to go, hey, something happened in Azure or AWS. I want to move to GCP, right? Great, done. It should be a 5-minute conversation rather than a 3-week intensive process of, having to go redo everything, re-architect everything, check all the memory limits, et cetera, et cetera.
3 weeks, you mean 3 years?
Yeah, well, yeah, exactly, right.
Yeah.
Going in and saying, hey, it shouldn't really be that hard and it shouldn't really be that long. If you standardize, to Derek's point, on open source standards, open source frameworks, look at configuration as code, right? Things like that. You can now make portability a reality rather than a massive project that it needs to be. Right? Yeah.
Mm-hmm. So any like misconceptions around this approach, like any gotchas, if someone was looking to get started with moving to this approach, like what are some hiccups they might run into along the way? Question to either of you.
I can tell you a couple right out the gate. A lot of people go into the cloud thinking Terraform is their gateway to being platform agnostic. The problem is all of the underlying infrastructure in those environments, even the terminologies they use, are wildly different. And so you end up rewriting your Terraform code for every environment. Now, at the end of the day, you look at that and go, well, at least it's still Terraform. And so you're not having to relearn the language, just rewriting the code. But that code could be thousands, if not tens of thousands of lines of code that you're trying to manage per environment. So that's thing number one. Thing number two is people go, because I'm in Kubernetes, even if I use Kubernetes as my landing place for Azure, AWS, on-premise, whatever, it's still married to the technology set, right? And the answer is that's a gross oversimplification. Kubernetes it's software to find everything. It's software to find networking. It's software to find storage. It's software to find service discovery, DNS. It's software to find literally everything. It's a software to find data center in a box. And it abstracts all those layers away from you. Now, do you still need some form of automation to stand up Kubernetes in this different environment? Yes, you do. But the amount of automation you need for that one simple task is about this big compared to all the different nested services you could use in a different cloud provider. So you're talking like 100 lines of code per environment that needs to be managed. Oh, this is how we spin up EKS versus GKE versus AKS versus OpenShift or whatever, right? It's a very small amount of automation code to get the system running. And then everything else, if you're being wise about it, can be done in an agnostic way inside of Kubernetes per environment. So it could be the same software to find storage, the same software to find networking, the same software security rules as it relates to how you're doing scanning, the same rules as it comes to monitoring and logging. Like it could all be ubiquitously exactly the same per environment. People go into this with this mindset of like, I'm just moving the needle to somewhere else. And it's like, not really, because all the other environments, they're not built on standards. They're built on unique ways that they do their thing. Kubernetes is a ubiquitous standard at this point that is being adopted and built in different distributions. But much like Linux, it is not different to go from Ubuntu than it is to go to RHEL or CentOS. There's different package managers, but it's still Linux at its core, right? And if you marry yourself to the core foundation of the platform, you can go from one environment to another, one distribution to another with ease.
So thanks, Derek. So how has this changed observability? Maybe Nish, let's start with you. You're in the observability business at Dynatrace. How has Kubernetes changed the game for observability?
I'll answer it in two ways, right? So one is it's made things way more easier, right? On one hand, right? In terms of like monitoring, workloads, et cetera, it's become much more automated, right? But then on the flip side, it's become significantly more complex, right? Because you have a whole bunch of, you've got Kubernetes control plane, you got, the things that launch services and pods and, so you've got multiple layers now, right? So if you think about historically the way you used to monitor, you'd have a JVM running on an EC2 instance, right? It was pretty easy. You'd go monitor that JVM and the infrastructure stuff and you're good. Grab a couple of logs and you're good now, right? Kubernetes now, because of the control plane, the different pods, a node, a cluster, et cetera, you've expanded the reach of observability that you need, right? Plus also you need to get logs from all of those different, it's honestly, it's pushed and changed the narrative for observability vendors everywhere, right? Because it's not just thinking about metrics anymore. Like it used to be, hey, I've got infrastructure metrics, CPU, memory, network, disk, I'm good. Well, not anymore, right? Because it is all software defined, right? There's a lot more areas that things can break, right? There's a lot more configuration that needs to happen now, right? If you go look at the bulk of Kubernetes issues today, right? It's got nothing to do with infrastructure. Like, it's really configuration. I didn't give enough memory to my pod. I didn't get enough cores to my pod. Hey, my CPU auto scaling, thing within the control plane is falling over because I didn't allocate enough memory in my cluster or my node. The breakpoints are significantly expanded, right? And so when it comes to observability now, you kind of break out into two parts, right? One is for the platform guys, right? Hey, I need to know if my platform's up and down. Do they really care about what's running on the platform? Kind of, but not really, right? And then you've got the application folks, right? Who are like, hey, I'm running on this new technology, Kubernetes, which is opening up my world to all these different possibilities. But I need to now know, hey, is it working or not? Is the reason my pod didn't start up, is it my fault or is it somebody else's fault? Is it the platform fault? Right. So the finger pointing is still there, but now it's just changed a little bit.
Yeah. Derek, any comments on that? I mean, is there more or less finger pointing?
There's probably more finger point. It's really about how you use your observability tool, right? So I've seen customers come into using Dynatrace and they come from different various backgrounds, right? And they're used to, you don't have enough information to say it's my fault. And I don't want to take responsibility because I don't want to be up at 4:00 in the morning trying to troubleshoot this. So I'm going to push it off onto another team because I found one little thing that indicates it might be somebody else's fault. What a tool like Dynatrace in this world does, besides, to his point, capturing more information, it takes all of that information and distills it down in a way that makes it way easier to figure out where something is going wrong in a needle in a haystack situation. So it's easier for someone to go, it looks like actually it's not my fault. Actually, it might be your fault, because you can see when it's not a memory or CPU or a network IO or a disk utilization problem. It is clearly the way the code is written because of the way this SQL payload is going to the database. It's using join statements in ways that are inefficient, and it's literally causing the database to collapse on top of itself, right? It's painting a much more thorough picture in a much shorter time interval. But the way that then gets adopted really depends on the culture of the company. If the culture of the company is built to be non-defensive in the sense that, hey, we're in this together, and when there's a problem, we work on fixing it together, you're going to thrive and swim beautifully. If your culture, on the other hand, is it's your fault, you're fired, this is kind of a really sad situation to be in, because especially with the complexity involved, you want to be of that mindset that we could point fingers, maybe because we're trying to solve the problem and not because we're trying to blame someone else.
I just want to kind of highlight something as well. This is just Derek brought up a great point, right? Is with the advent of Kubernetes now as well, right? Your problems, like for example, if you release bad code, right? That has a potential memory leak, like a slow memory leak or something like that, right? It gets exponentially exposed now, right?
Yeah.
Because in the Kubernetes world, you've got features now like auto scaling. You've got things like, hey, if my pod runs out of memory, just keep giving it more memory, things like that. And when you start doing, things like that, what ends up happening is you end up in a situation of cause symptom, right?
Yeah.
Well, okay, great. My Kubernetes cluster crashed because it spun up too many pods, right? The reason it spun up too many pods was because it kept giving more and more memory to this one pod because it kept hogging it all because I released poor code, right? Now that's the cause, but the symptom is my Kubernetes cluster crashed, right? Now in that scenario, though, what ends up happening is because of that high level of automation in the Kubernetes world, getting to that core symptom is really, really hard, right? You may just think, hey, especially when it comes to things like slow memory leaks and things like that, you just think, hey, it's a resource issue, man. I'm going to just give it more memory, right? But
Right.
then 2 weeks later, your pod's still running out. It's getting it out of memory again. Well, I'm going to give it more memory. Well, I'll give it more memory. You know what? I'm just going to automate it, right? And
Yeah.
then all of a sudden you end up in a scenario of like, oh my God, I brought down my entire cluster, right?
Yeah.
Um, so it's it is really changing the technology landscape, right? But it's also adding in a whole layer of complexity that that a lot of admins, not just admins to be honest, but DevOps teams, SREs, including developers, need to start thinking about in a big way, because the level of automation it brings and the freedom that it brings because of that level of automation is really changing operations.
Yeah. I like to say that it it opens the visibility to your bad habits being exposed really, really poorly in a humongous way,
Yeah.
where like it only makes you better because it's either going to train you to not do things inefficiently, or it's going to call out you for not being inefficient. And when it does, it's going to be in a catastrophic way that you didn't predict, right? So it's forcing you to not have bad habits anymore, which is in long term a good thing.
Yep. Absolutely.
So moving on to building for portability, maybe Derek, like walk us through a real customer example. How did they successfully move workloads between the environments, and what made that possible?
There's a couple of different things about this. So one customer I can think of in particular I worked with a few years ago, their team is in various cloud providers, predominantly AWS and on premise, right? But they had one team that was born in the cloud and this might have been from an acquisition or something like this, but their whole team was based around Kubernetes using kind clusters and EKS, specifically to manage their how they adopted AWS. Their likewise on-premise team was more of a traditional working group used to VMs and whatnot, and they wanted to marry up to what the cloud group effectively was doing. So what did they do? They adopt OpenShift on-premise in their VMware enclave in a slow manner that they could slowly bring in their workloads, remanage them, redefine them, start to learn what it's like to play in this environment, while the pros, so to speak, that have been doing EKS for a while were able to do so effectively in the cloud. And they initially operated almost separately from each other, where the AWS team was kind of doing their own thing in EKS and the on-premise team was doing their own thing in OpenShift and slowly bringing things over. But the goal in mind, they had really smart leadership, was always to merge these two practices together. And the purpose of that was to create exactly what we're talking about here, this infrastructure agility or infrastructure portability, where they could move from their OpenShift environment on premise to their EKS environment in the cloud without having to redefine anything. And the reason they were so successful at this is because they didn't do one of two things that I usually call it as really bad practices. Thing number one, they didn't just leave it in an isolated group. hey, the AWS people, they're going to do things in EKS and on premise, we're going to do our own thing forever. That's not the mindset they lend into. Instead, they let the people that were born in the cloud accelerate and use EKS and get really familiar with it. And they let the people at their own pace on premise learn how Kubernetes works in a slow manner while refactoring their apps until they could eventually marry up. That's great. The other end of the spectrum that could have went wrong is, hey, they're doing EKS. We're going all in on Kubernetes right now. We're cutting everyone out at the knees and just making you learn it immediately. That also has catastrophic failures. And most customers go one of two directions. Hey, this year our CEO says we're going to be all in on the cloud. And by cloud, we mean containers. And then overnight, they're trying to migrate everything and they end up failing miserably. So it usually happens one way or the other. It's not normally that you get to see companies be very methodical about how they approach these things with a target end goal in mind that differentiates from what the current operating process is. And they did so really successfully.
It's funny, it's like in my role, I obviously get exposed to a lot of customers, right, all over North America. And, one of the funny things is when you talk to the really agile shops, right, they've really thought about their architecture, their structure, how they're going to how they're going to run Kubernetes workloads. They've got a very robust tagging capability, annotations, labels, all that sort of stuff. And then, when back to your other point with the second path, which is like, hey, we're just doing this and everybody better get on board. That's where you end up where we've seen customers where they've got, Kubernetes pods that are literally like 10 gig each.
Right.
And all they've done is like they've basically taken that JVM and they just shoved it into this container and said, well, I need 10 gig. Right. And all they basically did was lift and shift. They didn't really architect anything. They didn't think, hey, could this be broken down into a microservice, whatever it may be. And it's very, very obvious kind of, hey, they were rushed into it. And so they just picked the easy button and said, this is what I'm going to do and let everybody else handle it. And versus the companies that have really gone in and said, let's look at this and let's look at this holistically and think, is this the best architecture for the best customer experience, user experience, reliability, uptime, whatever, right? Portability for that matter, right?
Yeah.
So Nish, maybe we stay with you. Folks listening or watching might think, the challenge of maintaining visibility across all these different workloads now in a multi-cloud environment. Like, how do you go about consistent observability in this new world?
Yeah, I think at the start, it really needs to be what do you want to observe, right? So think about it from the perspective of it used to be, again, don't just think about it of like, hey, what is my metrics, traces, logs, right? That everybody, when you talk about observability, they say metrics, traces, logs. Yeah, that's fine, but that's table stakes, right? Think about the platform. Think about platform health. What metrics do you really need? Where you truly understanding the Kubernetes control plane, how that interoperates, right? Things like now when you start throwing in things like Istio and stuff like that, right? The Calico network frameworks and stuff like that, PVCs, right? Do you have a robust logging strategy? How is the observability vendor going to handle that? Do I have to manually go in and go search for all my different logs that contain certain tags and all that sort of stuff, right? That's like, I always look at it from a producer's perspective and a consumer's perspective, right? Producers being the telemetry data, right? What is it? Metrics, traces, logs, real user, Kubernetes control plane data, etc. Right? What is all that telemetry data? Bring it into your observability system, right? So in this case, for example, Dynatrace, right? And then on the other end, it's the consumer side, right? So who's consuming it? If I'm a DevOps engineer, I have a very different persona and very different data that I need compared to a developer, compared to a VP of engineering, compared to a CTO, CIO, right? If I'm like a CTO, sure, I care that it's up and I care that it's working, right? But I don't really care if one of my APIs is flapping, right? But what I do care about is how can I optimize my Kubernetes workloads to go reduce my cloud bill, right? So, but you can still get all of that information from that data, right? Dynatrace can help with that for sure, but I think you need to start with that mindset of who are the personas, right? All of that data that I just spoke about generally in today's world lives in a lot of different silos, right? And so getting the answers that you need is oftentimes very difficult and very manual. So you want to align yourself to a vendor or even if you DIY, whatever, but you got to start thinking about it from the perspective of which personas am I going to be able to cater to, right? You can obviously do a lot of DIY with Prometheus and et cetera, right? Even Kubernetes emits a lot of telemetry data on its own, right? But then the problem becomes, am I going to have to go manually do this? And then what does it look like at scale? This is great for 1,000 pods and 2 nodes on one cluster. But what about 1,000 clusters? What about 1,000,000 pods, right? At that level now, you're talking about some serious telemetry data. And if you need to go figure out the signal from the noise, how are you going to do that? Right. Yeah.
Derek, any comments on that, or maybe the DIY approach versus going with a vendor like Dynatrace?
I think DIY, especially in the observability world, works to a very small degree. This is what I mean by that. The world has come up with different frameworks for operating, and I honestly have been kind of against it personally. And it's funny because I come from an open source background and open standards background, but I'll explain the reasons why. First of all, OTel and open metrics, they can capture a lot of things for you. The problem with relying strictly on things like open standards for metric collection and for things like telemetry collection is that it's based foundationally on that you were good enough when you were writing your code to include the right areas to be monitored. And the reality is the reason that APM solutions were even derived was because clearly as developers, most of us, and I shouldn't say most of us, all of us miss things, right? So it's fundamentally working from the principle backwards. How many people, let's not even talk about metrics for a second. Let's talk about testing. How many people write proper unit tests that are full test coverage for an application? I could list maybe one customer I've ever run into that I was like really impressed by the unit test coverage, but was it ever 100%? No, not even close. The reason why you leverage a tool like Dynatrace is because you're not relying on your ability to have properly captured with OTel and open metrics all the things that you would have wanted to see. Instead, you're relying on a system that auto-discovers all of the injection points that you might be having as an entry point into your application where possible and following it through to the end, regardless of whether you told it to be monitored or not, right? And that's, I think, where people get confused. They think that, oh, we'll just write things in accordance with the standards and that will solve for all of our monitoring problems. And the reality is you're going to forget something. You're going to. And you're more than likely going to forget not one something, but a lot of somethings just because you've missed them. Using something like Dynatrace, which auto-introspects your code to go find where there's issues, that makes a lot more sense to me. And I don't feel this way about a lot of things, but truthfully, in this kind of a paradigm, I don't know how you could approach it any other way and do so with the mindset that we're actually getting all the information that we really need. So I think it's a fallacy a lot of times that people go, well, we can rely on just open source standards and open source practices when it comes to monitoring and specifically root cause analysis. Right? I feel like that's where the cliff ends, because unless an open source system comes out with the same functionality of being able to auto introspect code, which there isn't, by the way, there's free APM or open source APM solutions, but they don't auto introspect. They still expect you to bring OTel or open metrics to the situation. That doesn't solve for the same problem. So that's my 2 cents.
Yeah.
If you go back to our example of the memory leak, right? For example. So, if you think about data on glass, right? So, hey, the metrics show that the pod ran out of memory. Fantastic, right? So your natural reaction is, well, I need to change my config and give it more memory, right? Now, if you're not introspecting your code, even OTel for that matter, right, would still tell you that, like, hey, because there's no memory profiling in OTel yet, right?
Mm-hmm.
So in that scenario, right, as a platform operator, as a DevOps engineer, as a developer, you literally would never have found that memory leak, right? And so the actual cause never would have been found. And all you would have done as an operations team, that entire operations group, dev, SRE, DevOps engineer, platform admin, whatever, all they would have done was kept solving the symptom,
Yep.
not the cause, right? And that's where you got to start asking the question of, like, hey guys, like, are we truly getting end to end? Right. And when we say end to end, we really mean everything, like even the users too, because, in order to understand why your systems are behaving the way they are, you also got to understand what people were doing on them. Right. Did I rage click this button because it didn't show up or it didn't do anything? And so I did that, or maybe because I inadvertently clicked the wrong thing and it, spawned off like 10,000 DOM endpoints or whatever. And all of a sudden now my front end is getting hosed. Right. Or alternatively, it's just poor design. Right.
Yep.
And your observability needs to be able to answer all of those, right? It can't just be metrics, traces, and logs. That's table stakes, right? How
Right.
are you going to automate the process of find, fix, isolate, and remediate, right?
Yep.
And throughout the entire process, it really should be automated. And then once you can solve for that, I would say that's like phase one. And then phase two needs to be, how do we go left? Right? How do I take that into my pipelines now to pass and fail bills to say, here's my deployment, here's the code I released. What is it going to do to my pod memory?
Yep.
What is it doing to my pod CPU? Right? And if it doesn't pass that, then you know what? It doesn't get promoted to production. Right?
Yep.
You got to start thinking that way. Yeah.
Thanks, Nish. We'll stick with you and head towards sort of business value and looking ahead. Right. So beyond, say, avoiding lock-in with infrastructure agility, what cost optimization, business benefits are customers realizing with this new approach?
Yeah. I mean, cost optimization is a huge one, right? At the end of the day, I look at it twofold. So one is that what it's doing is it's forcing the conversation of microservices, right? Re-architecting your platform, right? And what you can find is that, if you were running a monolithic application that had 20 to 30 different services all within one process, now you can go in and say, look, so many people are going to log in the morning, but they don't log in the afternoon. So why would I pay for that? Right. You can also start looking at things during high volume, like Black Friday or Christmas or things like that. Right. Maybe I need to spin up more infrastructure then, but then during we have customers that have come to us and said that because of us, right, and their ability to observe the workloads and all that sort of stuff, they were able to save upwards of around $500,000 a month, $6 million a year, right, in cloud cost optimization, because what they realized was the bulk of their traffic would come in for the last 3 days of the month, right? For the other 27 days, nothing. Right. So why were we paying for all this Kubernetes infrastructure, whatever, for the 27 days of the month that was never being used?
Right.
Right. So there's that. And then the second piece I would say as well is in this new AI world, we'll call it, right? Agentic is a big piece of that, right? So being able now to take that workload and use, the cloud provider agents like Amazon, Q, SageMaker, whatever, Azure, GCP as well, right? And say, hey, go take a look at my workload and what are the optimizations I can find, right? But using, say, for example, like in the Dynatrace world, we have our MCP server, right? We can now talk to, because of the Dynatrace MCP, that now puts the Dynatrace platform being able to talk to the cloud provider agents and start thinking about cost optimization for Kubernetes instances, Kubernetes workloads, basically any cloud workload you can think of, right? And that's a very, very exciting prospect and conversation to be able to have with, especially the C-suites, right? If I'm a DevOps engineer, do I really kind of care about cost optimization? Probably not. I'm probably more focused on resiliency, right?
Sure.
I'm probably more focused on uptime and availability. But my CIO, who gets the cloud bill, or CTO, who gets the cloud bill, he very much cares about that, right?
Sure.
So being able to answer both of those is really an exciting time. Yeah. Yep.
Thanks, Nish. So Derek, over to you. Like, what's one piece of advice you'd give a company just starting their journey towards infrastructure agility?
Most people are starting to look at this because of one of the three fires that we talked about earlier. The Broadcom acquisition, how expensive it's gotten, what happened in AWS, what happened in Azure. Don't rush into this is thing number one. And what I mean by that is don't rush into it. I don't mean don't start making plans to do this. I mean, don't rush the process of getting there. Some people will look at their Broadcom VMware licensing and go, I have 3 months until a renewal. Let's get into OpenShift Vert and let's move everything over tomorrow. Could you do that? Sure. And I'm not saying don't do that. But this is what I fear when people rush into this too quickly versus when they do it slow paced. If someone is, from an analogy perspective, told that, I'm going to teach you to get in good shape, and teaching you to get in good shape is going to take 12 months. And over those 12 months, you're going to get in really good shape and you're going to be healthy. And now you're going to have the tools in mind where you no longer need a trainer. You can go keep yourself healthy long term. You're going to go, sounds great. But then if I alternatively go, I have a pill you could take that'll get you in shape in a week, but we still need to make sure you learn best practices because this pill is a bandage. People are going to learn to rely on the pill and forget about the things they need to actually do to be successful. And so I say all this to say, don't rush into this with the mentality that you move everything into Kubernetes and now you're infrastructure agile. That's just not the way it's going to work. It's built on good practices, making sure you understand the technology, having the right team members on board. Adopt the technology as it makes sense for you, but adopt the practices of being infrastructure agile slowly over time while being right-minded about it. And when things fail because maybe you didn't do something right or whatever, don't be so quick to blame the technology. That's a big fallacy people run into. This didn't work because Kubernetes stinks. Well, maybe it's not that Kubernetes stinks. Maybe you're just making too many expectations for something that you haven't fully adopted yet.
But it's easy to blame the tech, right?
Doesn't have a personality to fight back, so sure.
So Nish, same question to you. What's some advice you'd give to a company on this journey?
Yeah, pretty much in line with what Derek was saying, right? Don't rush into it. Think, like, do your homework on who are the experts in that area, right? Don't number one, don't rush into it. Number two, think about observability from the start, right? Don't think of it as an afterthought. A lot of people, then they go into any type of cloud native project. They always think number one priority is to get it off the ground. Okay, great. But then the second thing is, like, how do we get visibility into this now? Because you're essentially migrating workloads to something that you don't own, right? And so when you think about, if you put observability as an afterthought, it typically will always blow up in your face, right? And then kind of back to Derek's point is number three, make sure that when you understand this journey, make sure ROI and cost is a big part of it as well, right? A lot of companies will say, hey, you know, we're migrating to the cloud. Fantastic. But then they run into this scenario where it's like, hey, all of a sudden now we've moved to the cloud and the performance isn't there, the ROI isn't there, you know, all these things. And then back to Derek's point, they blame the technology. Well, you know, it's Kubernetes is bad, and you know, we didn't think it was going to be that much. Well, I mean, do you blame the technology or do you blame the individuals that didn't do their homework? Right? You know, it's super easy to Derek's point to blame the technology, right? Because, well, you know, they promised me all these things, and yeah, okay, sure, they did promise you if you had configured it correctly, right? If you followed best practices, right? So my advice to anybody looking to undertake this journey is you should absolutely do it, but make sure you consult the experts and people that know what they're doing beforehand, right? You know, think about ROI, think about observability, make sure you have a baseline. This is what things were like before. Then when you move, you have a great understanding of this is what things are like now. So it's very easy to make the ROI justification. Right.
Right.
Yeah.
And
Great. Well, we're at the end of our time here, gentlemen. I just want to say thank you for joining me. We'll include links to Dynatrace and Shadow-Soft and Derek and Nish's LinkedIn profiles. Again, thanks for joining us.
Thanks for having us. Take care.